Classify each of the following. So is there anything on here that you feel like we need to review?
Not really. I'm fine with all of it. I'm probably gonna end up doing this quiz twice just to be sure. But
yeah,
I don't feel too uncomfortable with it.
So on the problem, classify each of the batting averages as either unusual or non-unusual. So use the Z-score to make this determination. Are they referring back to? Do you think they're referring back to the was 0.28?
I'm gonna pull that up right now.
Because they were talking about that in the workbook, the batting average. So which is 0.28. I don't know what are they going by the 0.28 or are they just going by the chart, which the batting average, they're all above 0.16. So all of these would be not unusual, as far as I can see.
So to complete these questions, classify each of the. So 0.19. With the first one, the first one's unusual, right? Because it's a minority.
Well, that's what I'm saying. Are they basing that on the 0.28?
I believe so. Yeah, that.
Or
the chart from the reading, yeah.
I guess I'm a little confused. What am I supposed to measure it up against? Because the medium would be about, or I guess what is that, the medium would be somewhere about 2 point.
Like 0.26, 0.28, somewhere in there.
Yeah, something like that. So I guess I'm not
because like it looks like about 18 or so people fall into the 0.19 on the chart.
I mean, they all fall between 0.16 and 0.36. So
yeah.
So are they wanting us to go by the medium, or
use the Z-score to make this determination.
Let me look at this. Let me look at this answer key again. I accidentally closed down the answer key, so I'm going to open it up.
Gotcha.
Oh, they go by the standard deviation. Okay, yeah. So the Z-score.
Yep.
There. Okay, so we're trying to go. We're supposed to be calculating.
Subtract the mean and divide by the standard deviation. Is that?
Let me tear it here. Okay. So the mean, do we have the mean based on this?
Oh, I don't think we do. Let's see, what would it be? What is the standard deviation for the information? Do we have that too?
That's what I'm trying to figure out. I'm looking at the workbook and I'm, because they're talking about, you know, trying to find out what the batting average above 0.28, but that doesn't mean that that's the medium. They're just using that as an example as far as I can see.
Yeah, that's just the problem they're solving.
Mm-hmm. But, and then they go on to the standard deviation of Ghana, the men in Ghana. So I'm a little confused as to where we're supposed to find the. I understand how to get the z-score. It's the let's see what we got here. So basically, you get the unit, right, 0.19 minus, or how does it go? Minus the standard deviation.
Oh, so yeah, we would take the 0.19 and subtract the mean, and then divide that by.
Yeah, divide that by the standard deviation, but I don't know where we're supposed to get the standard deviation from. Let's see. Subtract the mean and then divided by the standard deviation. Okay. I'm not sure where we're supposed to get that from. So the probably the randomly, oh, that's something else. Okay. I don't know. I'm gonna skip that for now. Maybe I'll have to figure that one out because I don't know. So it doesn't say where we're supposed to get the calculation from. I'm a little confused on that. So let's go to number 2. You want to skip to number 2? So,
oh, there we go. For some reason, my Google Hangout just dropped off.
I'm sorry?
I lost Google Hangout for a second. I found the information though. It's all the way down in 3.22 in the book.
I'm sorry, in the book?
Yeah, it has the mean and the standard deviation.
Where? On 2.2?
3.22. So it's down. It says baseball averages.
On the where it says density curves?
No, you're gonna have to go way down. There's gonna be like a little comic strip.
Oh, further down?
Yep. And it says normal probability applet, and then it's under there 3.22.
And you calculated it, it made sense?
Yeah, it makes perfect sense once you once you have the numbers to use.
On 3.22, you said?
Yep, 3.22. It says baseball averages,
Uh-huh.
and it has it in there.
Okay, so what is it? What did you say it was?
The mean is 0.261, and the standard deviation is 0.034.
0.034? Let's see. Okay, I still don't see it, but okay, I'll look it up. It's just,
Do you see where the comic strip is?
yeah.
So if you see if you go to right into the comic strip, there should say normal probability computations.
Uh-huh.
So then you scroll down, it'll say it'll be one chart, two charts, and then right after the second chart, it should say baseball averages.
Normal probability. Okay, yeah.
So in that
Population mean is 0.2. Oh, okay. All right. I just want to know where to find the okay. And then standard deviation is 0.034. Got it. Okay. All right. All right. So then the next question is that a randomly selected professional baseball player will have a batting average of greater than 0.335. So we do the mean minus the 0.335 minus the mean, right?
Oh, to find do we need to find the z-score? Or what do we need to do for that?
The probability that a baseball player, is that the z-score? Is that what it means?
I thought the z-score is only defined the usual or unusual.
The deviation, right?
Gotcha.
Yeah. So, but probability. I'm pretty sure it has to do with the mean. So 2.261.
Okay.
Normal probability computations. Here we go. Converting the z-score to a probability. Okay. So it's okay. The formula, according to this, the z-score equals x minus the mean divided by the standard deviation. And then, okay, that's the formula for the z-score. So the probability they randomly select, okay, I'm just reading here, a randomly selected Guinean woman will be shorter than Siwa is 0.79. And how did they get that? Type the z-score of 2.041 into two boxes along the horizontal axis of the graph. I'm just reviewing over 3.21, the height of Guinean woman. This is where we're supposed to figure out how to solve it. Click the areas under the curve until only the areas left of the z-score are shaded. I'm gonna have to review this a little bit more because
Yeah.
I'm not sure. I'm not sure how they got the 2. You see how they?
I think if you there's a little applet that you can open. I just opened it up, and you can type numbers into it. I think that's all we need to do to figure this one out.
Normal probability applet. We're on 3.2.
Yeah.
Let's see. That's a chart.
So what it says we can calculate the probability of proportions by plugging in the numbers into that. And then in the base spell section, to find the probability, it says type the z-score of 0.559 in one of the boxes below the applet. Click on the areas under the curve until only the region on the right is highlighted in blue.
Okay, so I'm looking at the chart that says normal probability applet. What's the area?
Oh, let's see.
Is that the z-score? Is that what you're talking about?
So we're gonna have to find the z-score and then plug that in under the applet. So
where it says z-score?
Yeah. So 0.335 minus
minus the mean, which is 2.61, right? 0.261.
Yeah.
And divided by the standard deviation, which is 0.034. Is that right? Is that what you're calculating?
Yes, 0.034.
Okay. .17.
Yep.
Or how far do we go? 3 numbers? 2.176.
Sorry, say that again.
I got 2.176.
I got the same. I guess we could put 2.18.
Well, that's what I'm saying. Should we average to the third or to the second?
If, I just plugged in 2.17 and it got the right answer, so I guess it doesn't really make a difference.
2.17. Okay.
Yeah.
On each side, right?
You just put it on the right hand side because it's positive.
Okay, it automatically puts it on the other one.
So then, what you'll do is you'll click on the blue on the left hand side, so it turns it white.
Turns on the blue on the left hand side. Why that one?
Because we only want the side on the right to be blue.
Okay, but why?
So the blue, when we put the z-scores in, it'll tell us the area of the applet outside of the z-score. And so we only want the area to the right because that's the positive, like that's the probability of them.
Because our answer was a positive?
Yeah, exactly. And so we don't want the area of the other side of the graph. So to get the correct answer, we can only have half of it.
Oh, okay. So that area right there is 0.015?
Yep, and that's the probability of somebody getting that batting average.
How do I save this this thing so I can use it again?
There's a little download button.
Little what?
Let me see if I can download it real quick. No, I can't.
This is something we need.
Yeah, no kidding.
Let me see. Oh, I can bookmark it.
Yeah, that's what I do.
Bookmark this page to Done. Okay. I'm going to make a note here. That is to normal probability applet. And that is to find the probability. That's to calculate or to find, whatever.
Mm-hmm.
Okay. Part 1, 1. Part 1, 2. 1.2. Okay. Should we go to the next one? Okay, I'm glad you pointed that out because I never would have found that. I need to pay attention to those little the stuff that's highlighted in blue, huh?
Yeah. It's I don't know. It's one of those things that if I wouldn't have read it, I wouldn't have known either.
Yeah. All right. So should we go on to 3? Provide a brief description of normal density curve. Describe the shape and the properties. Okay. Well, that's just a definition, basically.
Yeah.
And which I've got that over here. You got that, right?
Yeah.
Yeah. Okay. The following z-score formula. Please state what each symbol stands for. Oh, okay. Well, the z is z-score, and the x is the I don't even know how to describe that. X is the number that we're working with, right? And then the little thing that looks like a U is a mean, and the O is the standard deviation. Is that what you? Are you there? Are you there? Did I lose you?
Sorry, my Google Hangouts keeps cutting out on me.
Yeah, I don't know if it's my computer or yours. The definitions. It just the next question was to the definitions.
Yeah.
I know how to define this x. How do you? I mean, I know what x is. It's the number that we're working with, whatever it is.
Yeah,
The
yeah. So
is that the probability?
it'll just
Maybe
be the unit or whatever.
Okay, that sounds like a good definition. So the unit we're working with, right?
Yeah.
Okay, I'm writing down this formula because that is a formula that we need to know.
Yeah, I gotcha.
All right. In no less than 3 sentences, please define and describe the 68 minus 95 minus 99.7 rule. Ooh, where's that?
That is, where did it go? It's in the reading. I just gotta find it again. Okay, there. 2.2.1.3.
Describe the rule. So did you find it?
Yeah. It's closer to the top of the page. There's a little yellow.
Oh, at the top? Where at? Under what section?
Sorry about that.
Oh, there it is.
Yeah.
2.2.1. Rule for barrel shape. Oh, so that's the rule for barrel shape distribution, which is 68% of the data will lie within one standard deviation.
Yep.
All right. Write all that down, or should we move forward?
Oh, I have it all. I have that part written down already. You can write it down if you want.
Well, we can move forward. I mean, that's just.
Gotcha.
I'm just gonna probably copy and paste.
Yeah, same.
Notes that we need to review. Okay, these will be good when we're doing. Okay. All right. Because you can look at notes. Well, I don't know if when we do the big test, if we're gonna be able to have our notes out. But nothing else, we can always review our notes.
Yeah.
Quantitative scores in the GRE is 150.8 with a standard deviation of 8.8. Okay, so the portion of the GRE are approximately normally distributed with what? With mean?
I think it's just 150.8, and then the standard deviation is 8.
Yeah.
Yeah, it's just copy and paste.
Yeah, basically. And standard deviation is 8.8. I think they just want to make sure we're understanding these charts. Okay. What portion of the people who take the quantitative portion of the GRE will score above 165?
So we'd have to find the z-score again.
So 165. Oops.
And then if we plug that z-score into that normal probability.
165 minus the 150.8 divided by the 8.8, right? I'm pretty sure there's a chart somewhere where we're going to be able to plug this in. If not, I can probably make that on there. Right? There's probably a chart somewhere where we're going to be able to plug this in. Are you there?
My Hangout's cut out again.
Yeah, I saw that. Okay, so anyways, I got no, I was just saying there's probably a chart somewhere where we can plug in these numbers.
Oh, you can plug it into that same applet and it gives you the right answer.
What?
Yeah.
Wait a minute. What? Let me open that up then. Where do I plug it in?
You just put it in at the bottom. So you just put the 1.61 into the bottom, and then right-hand portion.
Right. Okay. You put the 165?
I got 161, but yeah, 165 will get you
No.
as well.
No, not the M. Okay, you're talking about the z-score.
Yep, the z-score.
Yeah, but I'm just saying there's probably something to calculate the z-score.
Oh, yeah. So you just use the mean and the standard deviation.
I'm just saying.
Oh, I gotcha.
There's probably somewhere where we can plug it in. But yeah, there's just the 165
gotcha.
minus the 150. 150.8, right? Divided by 8.
Yeah.
And I got 1.613. I don't know if we're supposed to. Or...
Yeah, that's the same that I got.
Okay. And that's the answer that they're looking for, I believe, in this section, right?
Yes.
Still don't know if they want us to round up that. Okay.
Yeah, that's all good.
If a student's score is 10th percentile, what would their corresponding z-score be? Oh, the 10th percentile. That's is the 10 the standard deviation?
8.8. The 10th percentile means they're like at the bottom of the pack.
So the 10th percentile means 8.8 times 10. That's how far away they are from the standard deviation. That's how many standard deviations they're away. Is that what it means?
I don't know. I just know it means that they're in the bottom 10% or they're like 10% or less, like from the bottom of the pack.
So what would be their corresponding z-score? How do you? That's what I'm trying to.
Yeah.
I don't know how we're supposed to find the answer to that. It's what
I'm trying to see if there's anything in the book right now.
Yeah, that's what I'm doing. Does that have to do with the that one rule we were reviewing earlier? If the z-score corresponding to the 90th percentile, click the regions of the graph. I'm looking at 3.4, calculating percentiles using normal distribution. Oh, type the number point. This is on this example, 90th percentile. Type the number 0.9 in the box at the top of the applet.
Okay. So just okay.
Go back to this applet. So I'm going to try the example first. Then, and the z-score is, the value is 1.2. What is that? Okay, that's not the number I got here. I put under area at the top, put 0.9, and I got 0.126. This says the value should be 1.282.
Yeah, I'm seeing the same thing.
Didn't type the number. Okay, I'm confused. Nothing yet. Oh, so this is saying to, oh no, that's not it. I put the z-score in, but okay. What does that tell me? There's a sample here, but I'm not sure how this applet is helping me. Okay, we calculated this. The formula. I don't know what that formula is called, but so we got the original equation. And now we have to find the x. I think there should be a shortcut to this that I'm missing. Do you see that formula?
Which one's that?
Solve for x. Under 3.4, calculating percentiles using the normal distribution. There's got to be a
3.4.
So you scroll down a little bit below the normal probability applet.
I gotcha. I see it.
And there's a formula there. I think that's what we're looking for, but so the way we find it is x standard deviation.
Mm.
What is the 1.2? The z-score. I know I'm a little confused, to be honest with you.
Yeah, this one is a little bit weird.
I'll go a little bit slower on this one. Okay.
Yeah, I'm with you.
Let me go back to that.
I'm gonna pull up the quiz real quick and see if there's any questions like this on the quiz.
Okay. You want to just try to do the quiz and we can...
Yeah, let's go ahead and just try to do the quiz. I'm looking at it and it looks like most of the stuff is pretty easy except for like the last set of questions look like it's going to be a little bit tricky.
Yeah, we can retake those.
Yeah.
We need to go over this a little slower so that we can... The good thing is that we got the answer key so we can review it.
Yeah, for sure.
But, I'm okay with here. Let's do this quiz. I'm pretty sure there has to be a chart to do this.
I feel like there would be as well. I'll look around.
Like I said, this if you play around with the workbook, there was a place where you get all the charts.
Gotcha.
I've got to remember how to do that because Mike showed me. I may have to meet with him again. So I'm just moving forward here to the quiz. All right. See if we can do this. Anyways, but that's at least we know this is where you find the formula for that. It's on section 3.4.
Sorry, what was that?
I'm just saying for that answer that we were struggling with, it's in section 3.4.
Oh, okay, gotcha.
So we can review it. I mean, if you want to review it later.
Yeah, definitely.
That's going to be important.
I agree.
All right. Let's do this. I'm pretty sure we're going to find an easier way to do this, and we're going to be like, oh, that's how you do it.
Yeah, no kidding.
The total area under a normal distribution curve must be equal to 1.
Yep. It's the same as just probability, right?
Yeah. Under certain, because we have the rules. You got the rules, right?
Yeah.
For the bell shape, so that's what it's under.
Perfect.
Under certain circumstances, a normal distribution curve can drop below the x minus x. No, it cannot.
Yep.
Because it says it has to be equal or above the horizon, right?
Yeah.
So a normal distribution curve is symmetric. Symmetric is the one where you're straight, right?
Yeah, symmetric just means it's the same on both sides. So it is.
Oh, so that's true.
Yep.
Okay, I had to think about that. Okay. Use the following image to answer the next 2 questions. Okay, we're going to go to our little thing. Which of the following elements in the figure represents the z-score? C.
Yeah, the bottom boxes.
We can answer that one. Okay. Which of the following elements of the figure represents the probability that the z-score is greater than?
Would that be B?
The probability that the score will be greater than, wait, what are we looking at? Which of the following elements of the figure represents the probability that the z-score will be greater than 1? That would be B.
Okay.
Right?
Yep.
That section right there.
Well, actually, thinking about it, B is just the area.
It's A?
I think it might be D, none of these. Because I might be wrong, but is B just the area? I didn't think that really had anything to do with the z-score, other than like the z-score determines the area.
Well, C is the c-score, though.
Yeah, C is the z-score.
So if you put D, that's none of these represents the z-score. That's not true.
Well, it just says none of these represent that the probability that the z-score will be greater than 1.
So you think it's none of these?
Oh, it's either B or D, because it could be B as well. It's just it's tricking me. That's what it's doing. It's a trick question.
Yeah, I don't know if it's asking for the area.
I'm gonna try D, none of these, and then
How about I try B and I'll tell you.
And then we can just flip flop however whichever one's right. Yeah.
According to 6895 rule, whatever, what percentage of the data from the bell-shaped distribution will be within the standard deviation of the mean?
68.
What are the rules?
Yeah, it's 68.
Mm-hmm. Did we put 68 in percent?
What's that?
Did we put a 68%? The percent mark?
I just put the number 68.
Suppose that z-scores come from a standard normal distribution. Use the normal probability applet to answer this question. What portion of the z-scores will be between -1 and 1?
I think all we need to do is go to that little chart it gives us and scroll out to the 1 and -1, and then it should tell us at the top.
For the applet? Okay. So you just scroll out. Just put.
And I think it should give us
Put a 1.
7.
So what portion of the z-score will be between point? What do you mean? What portion?
Oh, so if you
the area?
Yeah, exactly. It's just going to be the area in between 1 and -1.
So 0.8413?
I get 0.6793.
Wait, I'm sorry. Oh, the middle.
Oh,
yes.
Yeah.
So will be between -1 and 1, and that's 0.3173, correct? Is that what you're understanding?
Mine is it's coming up.
The answer was, if the answer was, you would enter. Oh, never mind. It's the middle between -1 and 1.
Yes.
Is at the top it says 0.3173.
Which part do you have highlighted blue?
The outsides. Okay.
Gotcha.
So highlight the inside.
Yeah.
0.6827.
Yeah, mine came out as like 0.67, but I think if it's in that ballpark, you're good.
Your answer's different?
Yeah, I got 0.673.
What? I wonder why. Did you put a 1.0 at the z-score?
Oh, I did. I just dragged it out. I didn't even think that.
Oh, okay. Yeah, you just put the 1 in it.
No, it's I got 0.68272.
Okay. Suppose that z-scores come from a standard normal distribution. Use the normal distribution applet to answer. What portion of the z-scores will be between -2 and 2?
So we just did the same thing.
I'm guessing. I guess what I was confused is, I thought the portion of it should be in the blank that we're looking at now. That makes sense to be the blue. Okay. We'll find out. Because I was reading it the opposite way. I was putting the blue on the outsides, and the inside I thought was our answer.
Oh, gotcha.
I thought the blank part was our answer, but no, it makes sense. Yes, the blues, obviously 0.9545 of it is in the blue, is in the middle. That should be the blue. You're right. Okay. You're right.
Gotcha.
Okay, what portion of the z-scores will be between -3 and 3? Interesting. Okay. 0.9973. Look carefully at your answers in the last two questions. What do you observe?
They all they all match the 68, 95, 99 rule, or 97, 99 rule.
Okay. Got it. Yeah. Okay. 99.7. Yeah. Okay. Use the following information to answer the next 6 questions. Ooh. Is that going to be the hard one?
I think this one's going to be a little bit tricky, yeah.
What portion of the population have protein requirements less than 0.6? Okay, let's see. Let's see if we can answer it. The amount of protein that individuals must consume is different from every person. There are solid theoretical ideas that suggest that the protein requirement will be normally distributed in the population of the United States. The protein requirement is given in terms of grams of good quality protein that must be consumed each day per kilogram of body weight. So G, the population mean requirements for adults is 0.65 grams. And the population standard deviation is 0.07. Okay. My brain is a little shambles right now.
So I think when we find the z-score and then plug it into that probability applet.
A portion of the population have a protein requirement less than 0.6. Okay, I'm not thinking. What did you say?
I think we just need to find the z-score.
Okay. Which that is the unit that we're working with minus the mean. So okay, the standard deviation is 0.07. And the mean is 0.65, right? Is that what you're understanding?
Yeah. So I think if we find the z-score, we can plug it in, and then it'll give us our answer, hopefully.
What's the standard? Oh, wait. So that's 0.60 minus 0.65 divided by 0.07. Is that what you're saying? You're doing the for calculation?
Yep.
That's it. I got negative 0.71.
Yeah, I got the same. So I think then we just need to plug that into the applet. So we just put in 0.71 in the z-score. And then it should, the area on the left-hand side, I think, should be the answer.
0.5223.
Which part do you have highlighted?
Okay. What portion of the population have protein requirements that is less than 0.6? So
so it should be that if you highlight the left-hand portion, I think, of that.
The left hand and the middle?
I just think the left hand.
Point. Because the Z-score is 0.7.
Mm-hmm.
Oh, yes, that makes sense. Okay. Okay, so the less than 0.6. Okay, so it's 0.2389.
Yeah, so mine rounded out to I put 0.7 or 0.714 in there, and I got the.
Oh, you did put that. Okay.
Yeah, so I got 0.238 as the area.
That's why I wasn't sure how far we write those numbers. So wait, not the area. So 0.2376.
Yep. Mm-hmm. Yep.
Okay. What portion of the population have protein requirement that is more than? So then we highlight the other two,
Yeah.
right?
Mm-hmm.
That one off, and we highlight the other two, and it's 0.7624.
Yep.
Okay. What portion of the population have a protein requirement that is less than 0.70? Point 7624.
Hey, so when I did it, I got the exact same answer. 0.714 is the z-score. I think what we have to do is, so the z-score will be the same. I think we need to highlight the left-hand portion and the middle portion to get.
Yeah.
Okay. Yeah. 0.7624. Yeah, you're right. You're right.
Yeah.
Ooh, they're being tricky with us.
I'm just trying to figure out if we were supposed to just plug in this 0.70 in there.
No, I think you're right. Because if you do all the z-score stuff, it comes out the exact same.
Well, yeah. So right now we're working with the z-score. I'm just okay. I was just wondering if we were supposed to be using that number they have there, but okay. Find the probability that a randomly selected person will have a protein requirement between 0.6 and 0.7. So that's the one that we just do the middle.
Gotcha.
I mean, that's what I'm guessing.
Mm-hmm.
Or that's what I'm trying to figure out. Are we supposed to put? No, we can't put. We're not supposed to put 0.6 or 0.7 because then that would you have to put one or the other. So based on this, it would be the middle, right? Based on the z-score that we calculated.
I feel like it would be. I'm trying to. What is this hint it gives us, though? Remember that to find the area between two values, shade to the left of each z-score you calculate, and then subtract the smaller area from the larger area. What does that mean?
Shade to the left. To the left of each z-score, but that would mean the left of negative 0.714 would be, that where that bar is
Uh-huh.
to the left, and then the left of the 0.7 would be the middle section. Saying take away highlight the middle and the left side, and then the right side would be your answer. Subtract the smaller area from the larger area. So it would be 1 minus 0.7624, which we already know that would be the right side.
Yeah.
0.2376. But that's not. The question is, what is between? We should answer positive. This is the probability the random selected observation will lie between the two values. I'm going to go with the. I'm going to go with the 5 point.
I just found the section in the book that explains it.
Okay.
I'm reading it right now.
What section was it?
It's right under where you download the normal probability applet. It's section 3.3. It's finding the probability of being between two values.
Mm-hmm. Well, according to this one, the z-score for the first one was 0.82, and the z-score for the second one was 1.22. Is that what you're looking at?
Yeah. Mm-hmm.
Calculations. Find the area. I'm going to do this. Let's see. To the left of z, (1.22), which is, why is it 0.8888?
So that's the area they found in the first z-score.
Yeah, but where on the earlier? From earlier?
No, that's just from the book. We haven't done that equation.
I'm just trying to, if I follow this, I'm trying to figure out where would I get that what I'm subtracting. Oh, so I'm guessing subtracted from a 2, 1.22. 2 minus 1.22. Let me see. No, that's 54.78. How did they get that? I don't know. Do you understand where they get their numbers from? Because even I'm looking at this and I don't understand where they're getting their numbers from.
So for the equation, I feel like where they're getting their numbers from the applet. So if you take their numbers and plug them into the applet, that's the numbers you get. So if they find the z-score, then they plug it in. And so what we need to do is when we go to the applet, it'll still be that 0.714. But for the 0.6, we need to shade in the far left-hand portion and then subtract that from the middle portion.
So we do the subtract the 0.714 or just the 0.6?
I think we need to subtract 0.2376 from 0.5248 is what I think. Or
what was
maybe
that?
maybe it's actually 0.7624 minus 0.2376.
0.714 negative 0.714 minus 2376.
So it's going to be point. I think this is right. 0.7624 minus 0.2376, because that's all the area left of the bigger z-score, which is 0.714, minus all the area left of the smaller z-score, which is negative 0.714.
I'm confused where you got the 764 from, 0.764.
The 0.714?
This 0.64. I thought you said subtract 0.764.
So that's everything highlighted in the applet left of the higher z-score. So it's the left section and the middle section highlighted.
Oh. Gotcha. 762 minus the
minus just the left section highlighted.
0.2376.
Yeah. Mm-hmm.
I'm not really sure. I got a 0.5248.
Yep, that's what I got too.
Find the 35th percentile for the protein requirements for adults. There's that formula again that we have not mastered yet.
Yep.
Here it is. Original equation.
Okay, I think I get it. So what we need to do is we plug it into the applet. So we'll put highlight just the left-hand portion first, and then after you do that.
But first, what do we Okay, highlight the left hand. Go ahead.
Yeah.
Not the middle.
Not the middle, just the left hand, and then type in
Okay.
0.35 for the percentile.
For the z-score?
No, for the the area up in top, 0.35.
That's the percentile?
That's the, yeah, so 35th percentile, we want that to be in the area, is what the textbook says. And so then what we're going to do is we're going to, or do you have that in there?
Yeah.
So it should give you a
at the top I put, on the, where it says area, I put 0.35.
Yep. And so it should give you a z-score of that left-hand side of negative 0.38.
Uh-huh.
So then we have to solve the equation kind of like backwards for that number. Because you know how usually we have the z-score equation to solve to find the z-score?
Okay, so we do the z-score backwards?
Yeah, we just like solve it in reverse.
So the z-score equals negative 385?
I just have negative 0.38. I didn't get the 5 in there, but I'm sure it'll be close enough either way.
But it's the z-score, so
yeah.
And then so
and so then we multiply it by the standard deviation. So that is 0.07.
Oh, I'm sorry. Where'd you get the standard deviation?
It's from the beginning of the information. The what?
The protein?
Yeah. It's just that it's still that same information from the protein stuff. And then
I don't see it, but where was the standard deviation? Just remind me. Oh, standard deviation was 0.07.
Yeah, 0.07.
Okay. Oh, okay.
And then we'll add 0.65.
Plus point what?
0.65.
And that's because that was the mean. Okay.
Yeah.
So it's 0.676.
That's what I got too. Hopefully that's right. I know that that's at least like the only thing that could be different.
It's like algebra, right? You do everything backwards.
Exactly. Yeah. The only thing that could be wrong is if we use the wrong number from the beginning. But if that's the case, then we'll just go back and we can redo it.
Oh, now we got to find the 80th percentile. So we put the 0.8 on the top. How many more do we have? Oh, that's the last one. Find the 80th percentile protein requirements for adults.
So this time, highlight highlight the left and the middle because it's such a high percentile, I'm pretty sure.
Mm-hmm.
And then we'll do it with the z-score on the right-hand side.
So again, we just do the, let's see. I need to write them.
So 0.842 times 0.007 plus 0.6. Okay, I got 0.644.
Just remind me how you got that formula again. Okay,
Yeah, for sure. So it's just that z-score in reverse. So the z-score is
so minus negative 0.84 times the 0.07.
Yep. And then add 0.65.
65. Okay. Gotcha. I gotta write my formula in reverse so that I can
Gotcha.
next time I can just look at it, you know?
Yeah, I gotcha.
Plus. So 0.70894. Because I'm putting it to number 3. Is that what you have? 0.708?
For
0.7.
I got 0.644 for the answer.
Okay, I calculated 0.842 times 0.07 plus 0.65.
Yeah, that's what I did as well. Let's see. 0.84 times 0.0.
Oh, negative point. I have to put the negative in there, right? 842. That's probably what I did wrong. Times 0.07.
Wait, now I got a different answer. Let me redo this again.
Plus 0.65. Because you've got to put the negative in there, right?
Which negative?
At the very beginning, it's negative 0.842.
No, it's actually going to be the positive one.
Oh, it's the one in the positive?
Yeah. Okay. So I just got 0.708. I think that's
0.842 times 0.07 plus 0.65. I still got 0.708.
Yeah, that's the right answer. I did it wrong the first time.
Oh, okay.
And that's the last one, so I'm going to go ahead and submit it.
Well, let's see how we did.
100%. Hopefully. No, hopefully.
Like we did. Come on.
Oh, I missed one.
Going slow.
I missed 2. Oh, okay. So we did question 17 wrong. And then the one was right where you put B and I put none of these represents. So you got that one right. So you should have got 19 out of 20.
Let's see. You're right. But I got us 18.
Oh, you got 18?
What did I get wrong?
Which other one did you get wrong?
Number 17, I got wrong.
Yeah, I got that one wrong too.
I got to review that one. And then number 10.
Number 10. Oh, shoot. I got that one right.
Why did you get it right and I got it wrong?
What did you put for the answer on that one?
Suppose that the C-scores come from part.
Yeah, it should have been the middle part. What was your answer for it?
I don't know, but the answer is 0.9545, which
is... That's the answer that you put?
No.
Yeah, it is.
No. That's the answer that I put?
Yeah, because my answer is 0.955, and I got it right.
So I put 0.9545?
Is that what you put? Because I just put 0.955 and I got it right.
I guess what I'm saying is that 0.9545 is the same thing as 0.955. You're just rounding it.
Oh, gotcha. So
that's the answer. That's the correct answer.
Gotcha. Okay.
So I put something else. Okay, did you highlight the middle part? Is that what number you got? You put the blue and that's the number?
Yeah. Mm-hmm.
Okay, I'll just retake it and see what I did wrong because I don't even remember what I don't know what oh, well, here, I can do it real quick, right? I can just put -2. I'm curious to see what I did wrong here.
Yeah, I gotcha.
Highlight the middle. And it should be 0.9545. And yours at the bottom under question 10, it says the answer should be 0.955?
Yeah. Because it told us to round to 3 places for the answer.
Where does it say that?
It should have.
Oh, you're right. I didn't follow instructions.
Gotcha.
Okay. The answer is correct.
Yeah, it just needs to be
but
rounded.
I didn't follow the instructions.
Gotcha.
Oh, that is so dumb. Okay. I should redo this one. Okay. Hey, that's great. So you figured out how to do that. So then I just need to write down this formula with the symbols so that I can remember how to do it. That backwards one.
Hey, sorry, my thing cut out again.
Okay, hey, thanks so much for your help. I think we figured it out. And I guess I'll see you next week, and I'll submit this, and then next week it's your turn, right?
Sounds good, yep.
All right, thanks a lot. Have a good day.
You too. Bye.